Check, check. Hello, hello. Good evening, good afternoon, good morning, wherever you are in the world. Thank you so much for joining us. My name is Daniel Anthony. Welcome to the first workshop series of the Polkadot Solidity Hackathon 2026. It's a real honor to be here. My name is Daniel. I'm the Polkadot DevRel for Malaysia. And just to get everyone started, I hope everyone has already joined our Discord. If not, we'll be putting a link up on the screen between sessions and you'll be able to scan that QR code and join our Discord. Another thing is that for this workshop, there will be a NFT that you can mint, .memo NFT, also known as a POAP in some circles. This is for you to be able to mark your participation in the Polkadot Solidity Hackathon workshops. Now, without further ado, I'd like to get started with my session. I'll be covering a Solidity fast start with a Remix. For those of you who aren't familiar, Remix is the leading Solidity integrated development environment. Excuse me. All right, so to introduce myself once again, my name is Daniel Anthony. I am a judge and a mentor for the Polkadot Solidity Hackathon 2026. I am the Polkadot DevRel for Malaysia. I am based out of Kuala Lumpur. I've been on Ethereum since around 2016, been messing around with Solidity for a few years now, and I joined OpenGuild last year into 2025. So basically, you want to get into blockchain development. Well, a lot of people think about this field as either something that is extremely challenging or extremely easy. It's almost like there is nothing in between, because when you look at blockchain development, sometimes people think about the difficulty of having to program money, but while some also see it as perhaps there are a lot of templates out there. And honestly, looking at the field, you can feel really, really intimidated looking at all the words and all the buzzwords surrounding what it is to be a blockchain developer. Now, blockchain development can be intimidating. I'm going to be the first to say this, but at the same time, I am also going to say that it is something that does require you to filter out the wheat from the chaff, to be able to identify what people are talking about and separate buzzwords from the actual functionality of the blockchain. So today, again, a really fast start. We've only got about half an hour on this first session because we've got more workshops coming up after this. So don't go anywhere after my session. We've got sessions on how to use Rust for PVM, how to integrate front ends. There's so much more coming up tonight. We're so excited to get started for this first workshop. So, let's get it going. Let's talk about code execution. Blockchains with Turing-complete execution layers like Ethereum, they can run programs. And almost all blockchain execution layers are sequential, so there's no parallel execution on a blockchain. The basic way of explaining what a blockchain is that a blockchain is a deterministic state machine. In most cases, a blockchain is a distributed deterministic state machine, but that's not always the case. There are private blockchains, there are also local blockchains, as we will explore later on in this workshop. And on blockchains, every single transaction, regardless whether it's for programs or for transfers, they require a cryptographic signature from a wallet key pair. Now, you know what else requires a signature at the bottom of it in order to be effective? That's right, a contract. That's why blockchain programs are called smart contracts. So I want to talk about smart contracts in the wild. So now when you hear the term smart contract, it feels like this is a very abstract little thing that appears here and there in little sparse parts of the crypto and Web3. But in all honesty, smart contracts are actually everywhere in crypto. They're all over the place. Meme coins, a lot of them are powered by smart contracts. Non-fungible tokens or NFTs are all powered by smart contracts. ICOs or initial coin offerings, most of them smart contracts. Prediction markets like Polymarket, decentralized exchanges, some of these operate on a multitude of smart contracts all connected together, including escrows, marketplaces, and even some auctions. So how does this work? How are coins smart contracts? So we have to take apart what it means to have a program, what it means to record certain things, what it means to see certain things, what it means to be able to check and program certain things. So when you're talking about a coin, you can piece it apart by having the coin have a name, or the program has a name, and then you would have something like a little way of keeping track who owns how much. So you would use again, if you're not familiar with the keywords here, don't worry, we'll go through them later in this presentation. But you have this second line on the screen saying mapping address to a number. So that means, okay, how much does this address have? An address is basically a wallet or a contract in crypto, in blockchains. In Ethereum particularly, we use addresses to refer to either contracts or wallets. So because of that, we need to be able to say, hey, my wallet has 10 coins, your wallet has 8 coins, this other person's wallet has 6 coins. And if there is a wallet that has no, and if there is a wallet that is checked that's never interacted with this coin, you'll get the default value of 0. Then, of course, you need to be able to interact with the coin, and that's why you have functions. So you'll have a minting function to create new coins and a transfer function to send coins to others. And that's it. That's what a basic coin is. And NFTs are also smart contracts. It's also something that some people have misunderstood in the past, that NFTs are just abstract things also. But no, NFTs are also all just simple blockchain programs at their heart. So we'll piece through this simple program, again, the contract name. And now you have a unique index, because now each token can have a unique owner. So token 1 can belong to me, token 2 can belong to someone else. And how do we do this? We record the owner of each token through the ownership record. So that means if we ask, hey, who owns token number 1? Who owns token number 2? These are basically like serial numbers. So when you have objects with serial numbers, each one can have a unique owner, or they can be, and they're basically supposed to be atomic. They're supposed to be in integers, so that means you don't have something that you can split up. The whole idea of what a non-fungible token is basically in the name, that they're not interchangeable with one another, and in this case it's because they all have different serial numbers or indexes. And of course, just like the coin, we have minting functions and transfer functions. This enables the coin, or the NFT in this case, to be able to function and be transferred. Now we'll talk a little bit about functions and how they appear. And of course, after this, what we're going to do is we're actually going to go into Remix, and we're going to do a little fast little speed run on writing a smart contract, so that you can actually see all of this in action. But these are basically the principles that I want to go through in order for someone who wants to take on Solidity programming. So how do you basically get started? The main objective of this workshop that I'm doing right now is also to kind of like dispel the kinds of things that make people feel intimidated, make people feel scared of going into blockchain programming. And that some of these fears are well placed. Some of them are actually just floating around because of a lot of buzzwords and a lot of business talk that goes around in the Web3 industry. So in function state mutability, there is a basic rule. If you don't change the state of the blockchain, meaning you don't change a number or you don't change something, what I mean by change is that, let's just say you change who owns an NFT. If you don't make a change, you don't need to pay. So we've got 4 state mutability types. We've got pure, that means referring to this thing does not require checking the state of the blockchain. It exists on its own. It can be run in isolation. There's view, which references the state of the chain. There's payable, which requires you to send native tokens. On Ethereum, it's Ether. On Polkadot, it's DOT, that require to be called. Now, this function, payable functions are like functions to donate, functions to purchase, because you need to send money along with it. And finally, there's the non-payable. And non-payable doesn't mean you don't have to pay. Non-payable still requires you to pay fees, but you don't need to send any money other than the fees. And basically the fees are going to the network, not to the recipient or basically the contract or anything else that you're calling. And on Ethereum, fees are referred to as gas. And I know this is a little bit of a weird term for some of you, that, why suddenly are we talking about gas on a blockchain? Well, it's got nothing to do with fuel or gas. It's just a sort of an analogy to show that, you're paying for your use of the blockchain, you're paying for compute, you're paying for state change. So on Ethereum, gas is actually not deterministic. It's sort of semi-deterministic, but we can't assume that it is deterministic, unlike blockchains like Bitcoin, where on Bitcoin you pay satoshis per byte, and therefore you can actually estimate how much your transaction will cost before you even send the transaction. But on Ethereum, it's a different story. Gas is required for all transactions that modify state, as I mentioned earlier, and they have 2 main parameters. So we have the gas price, how much you pay per unit of compute, and a gas limit as to how much gas you will use before you give up and say, no, stop this. The reason that's important is because I'll explain in the next slide. Execution may complete or may not complete. In some cases, it will revert, that means fail, without using all of the gas. So therefore, you can calculate the maximum amount that you will spend on a transaction, and it may not reach that maximum amount for a variety of reasons. Now, Ethereum is Turing complete. Solidity is a language that's Turing complete. And any Turing complete language comes with Turing's halting problem. If you're a computer science student, you may have studied this. There's also plenty of YouTube videos about this interesting philosophical problem by Alan Turing. And it means that there's no general algorithm that can determine whether any given program will halt or run forever on a specific input. Now, the keyword I want you to focus on here is run forever. What does it mean when a program runs forever? On a computer, it means maybe it will hang, maybe it will just occupy threads, occupy your memory, and just never end. But on a blockchain, that means you're continuing to pay for compute until basically you run out of money, until you run out of Ether on Ethereum or run out of DOT on Polkadot. That's why earlier we said there needs to also be a gas limit, the second thing that you need to specify when doing transactions. Without a gas limit, an endlessly looping function depletes your wallet before it can actually revert. And the more complex the function, the higher the gas limit needs to be. So I hope that wasn't too much to process, but it's basically trying to take this from principles. I'm going to go through learning a very quick 10-minute crash course on learning Solidity. Now, I understand that for those of you who already know Solidity, this is very basic. For those of you who don't know Solidity, this can be a bit intimidating that we're going really, really fast today. But there are plenty of resources you can refer to about this that can, boost your knowledge. I hope this will whet your appetite and also encourage you to participate in the Polkadot Solidity Hackathon so that you can make the best of what's about to come. And of course, the idea of participating in a hackathon for a brand new language can be also a little bit off-putting for you. But the thing is, it's actually quite a simple language to learn. And one of the great things about Solidity being around for so many years is that Solidity is very established. There's plenty of materials out there. I wouldn't consider myself a master engineer of Solidity, but there are plenty of resources that you can refer to. I hope this whets your appetite for it. So let's get on with it now. When you're coding on Ethereum, you are coding on what we call the world computer. And this is the concept that applies now across all the blockchains that use Solidity. So when you're coding on Ethereum, in this global computer, memory is expensive and all operations come with a cost. We kind of went through the cost just now with how gas works. Now, this is also a realm where code is law, deployments are immutable, execution is trustless, and things are composable and permissionless by design. So what I mean by all this, let's go through one by one quickly. First, code is law is today's interpretation of the phrase that we may have heard growing up, that the computer is never wrong. It means that if it computes, it executes. There is no room for appeal or reversal. If something makes it to the blockchain, that means, yes, it was right. There is no appeal. And this builds into the second thing where data is immutable. The blockchain persists everything. So once it's included, once it's deployed, data cannot be erased or overwritten because history is also persisted in the state of the blockchain. Now, what this means in combination with code is law is that mistakes are forever. And this is something that I think most people need to learn from the get-go as well, because it's not something that can be taken lightly. Again, we're dealing in the realm of programmable money here. It's not like this is basically you screw up, you redeploy the whole application, you delete whatever was in the past, or you go inside SQL injection, change your database. It does not work like that. So what is composability and permissionlessness? These are also some things that sound like mega buzzwords that have been floating around X and the entire community, where people talk about, crypto and Web3 and everything along those lines. So data is public and transparent on blockchains. You can build by querying the state of the chain without having to use a third-party app or a provider, and everyone can access the state. It is public knowledge. So what you can do is that now that all the knowledge is out there in public, you can build protocols and build applications without having to ask permission. And this is very powerful because, you can now build into this ecosystem of entire apps that have public records. So like for instance, people have deployed their own coins, their own stable coins, for instance, and anyone can use those stable coins. You can build your own programs on top of those stable coins. You don't need to ask permission from Tether. You don't need to ask permission from Circle. You don't even need to ask the creators of meme coins whether you can use their meme coins or not, because again, it's now running in public infrastructure. Now, the part about atomic composability is a little bit confusing, but it kind of means that it's easy to predict whether, not so much predict, it's easy to work on Ethereum because the entire execution chain for a function, everything must happen in one block. You don't need to think about what might happen in the next block because that is another function, that is another call, that is something else. Execution is all or nothing on Ethereum. And by extension, that works for Solidity as well. And Ethereum is syntactic, and this is where Solidity comes in very importantly, because the Ethereum bytecode is universal. There's basically only one bytecode that works on Ethereum, and by extension now the EVM on Polkadot. So all programs and contracts run in this same environment. You're able to interact with other programs because it's not the difficulty of dealing with multiple runtimes, not dealing with multiple different environments in the same space. So you have this syntactic common ground that allows people to build easily and also build permissionlessly. Again, it's hard to filter out what the buzzwords mean because it's very easy to just go onto Twitter and listen to a couple of people spew these words and think it's either intimidating, think it's either very intelligent, or think it's either very smart. But when you actually boil down and try to understand some of these terms, they can be a little difficult. So if you're lost, what I suggest is make a note of these words and look them up, because these are actually some of the best parts of developing on blockchains, to develop for blockchains, because these are things that bring Web3 to life. These are the things that make sure that Web3 is a technology that is new, that brings something to the future. Now I want to talk about trustlessness, because trustlessness is also a difficult concept to understand. But for this example, I want to show what it's like to develop a Web 2 app versus developing a Web 3 app. So when you're on Web 2, you usually make an API call to a data source, and the data source will then dig out that data from their private server through Amazon S3 or wherever they're storing their data, and then return that data to you. Now, the problem with this is you have to trust that that data source is not lying. And I can't stress this enough when I go out and do my workshops, that I think we have not swallowed this bitter pill among developers that APIs can lie. APIs are not always honest, and some of these will do this because of various reasons. Some of them would be because the developers believe that they can abstract away certain information, etc. And sometimes APIs can just outright be inaccurate or dishonest. But in Web3, you don't need to worry about that, because you can query your node of the blockchain, and your node of the blockchain is incentivized to be in sync with the rest of the blockchain. So therefore, the data is public, because the data source, any other application on the blockchain, they have to write their state to the blockchain in order to work with it. So you can also query that same state from the blockchain. This way, you don't have to trust that a data source is being honest, because you can run your own node, make sure it is tallied with what's on the chain, and make sure that it has, it is synchronized with what everyone else has. You don't have to trust that it's all right. You're actually making sure that it is all right. Now, there are some exceptions to these principles, even though some blockchains do not uphold all of these principles. Some blockchains have actually hit rewind, as in, all the stuff that I talked about, that things are permanent, things are forever, they have actually hit rewind and erase some of those. Yes, Ethereum is on that list. It actually happened in 2015 after the DAO hack. These are blockchains that sometimes, they may not follow their principles correctly. Some blockchains are permissioned. Polymesh is a permission blockchain, means you can't exactly transact as you would on a public permissionless blockchain. Now, as a builder, I'm not saying you should completely write these off, but when you choose a place to build, before you even choose a place to build, you should still build with the best principles of blockchain development in mind. And the reason for this is because you ideally want to build good programs, build good software that everyone can use and everyone can share it. Now, how do you look for blockchains that uphold these principles? You look for two main factors. You look for one, an established history. That means a blockchain with a high block height. Many blocks has an established history, means it's most likely going to be around for the long run. And the second thing is the Nakamoto coefficient. And Nakamoto coefficient is essentially how many computers, servers, or nodes need to be compromised in order to compromise the blockchain itself or shut it down. There are blockchains out there with this number in the 4 figures, 3 figures, but you'll be surprised that many blockchains have this actually in the single digit. So if you can check a Nakamoto coefficient, it is a bit of an abstract number. It is hard to accurately calculate because there are many other factors and variables that are involved in calculating a Nakamoto coefficient. But this is one of the best ways to approach choosing a great blockchain to build on. So Solidity is a high-level language. It is Turing complete, statically typed, object-oriented, imperative, and it's influenced by Java, C++, and Python for certain things. There are things there's visibility in Solidity, and again, this may seem weird because we were talking about things are supposed to be transparent on the blockchain, but this is more towards whether a function or a variable can be accessed. So public means anyone can access, private means can only be accessed or called within a certain contract. Internal means that it can only be accessed within a contract and any derived contracts, and external means can only be accessed from outside the contract. Now you'll notice that private is actually the most restrictive visibility of all, because it means that no matter what, this function or this variable is only accessible within this very contract. There are typical data types we're dealing with here. There are many data types out there, and on Solidity, these are the main ones. We've got 2, value types and reference types. So we have unsigned integers and signed integers. These are numbers. They default to 256-bit numbers, but Solidity allows, especially because, again, we mentioned memory is expensive on Ethereum. So therefore, you can actually have integers from 8-bit all the way up to 256-bit in 8-bit increments. Both for unsigned and signed integers. You have booleans, which are essentially zeros and ones, but you specify them as true or false. There are addresses, and addresses are basically 20-byte hexadecimal strings. They reference either a wallet or a contract. And enumerables are custom types that have a finite set of constant values. You can name those constant values if you want as well. And then there's reference types. There's textual data, strings. We all know what this is. Don't leave home without it. We have arrays, mappings, and structs as well. So these things I hope you can look up in your own time, because we don't want to spend too much time going in onto the advanced stuff in reference types. But we will go through a very brief contract right after this. But just before that, we need to talk about where the data is, because it seems a bit weird that we're looking at this blockchain. It seems like such an abstract thing once again, and trying to imagine it as a computer. So in data location, storage and memory, again, very expensive on the blockchain. You can put data in 3 locations when doing functions. First is call data, read-only section of memory, use it for function arguments. That's what they're good for. They're discarded after execution. And generally, it's cheap to use call data. Memory is a bit more expensive because it's mutable. You can modify this data in the memory. So you can use this to change data types. You can use it to concatenate or drop certain parts of the data, and concatenate or truncate. Yeah, that's the right word. And the last one is storage. Storage is written to the blockchain. That means it changes the state of the chain. It persists forever and is the default for state variable. So if you declare a state variable in your contract, yep, that is written forever. The main components of a contract: first, we state the version of Solidity, the name of the contract. We put in some functions. Functions may need parameters. We have variables that store values. We have modifiers that can repeat certain code in certain functions. Some contracts have constructors, which is a function that runs once at deployment. We have events that help to communicate beyond the chain. And of course, sometimes we have interfaces, which is a contract blueprint that contains just function signatures to be implemented. So let's look at the anatomy of a very simple Solidity contract like we looked at just now. So first, you have a license string. You don't need to put this license string in, but if you don't do it, Remix will make a lot of noise, and most IDEs will give you a warning. And it's good so that we make sure that when we see your code, we make sure we know what can and cannot be done with it. Second is the Solidity version, and this is important because for the Solidity version, we recommend at least 0.8.20 for Polkadot's REVM, or just the EVM layer of Polkadot Hub. The contract name goes in the next line, and then the rest you have your variables, your constructor, and your functions. Tonight we'll be talking about the Remix IDE, and we'll be demonstrating that in a minute. But there are some others out there, particularly Hardhat and Foundry, very popular Ethereum development environments. And I'm also pleased to say that their Polkadot equivalents are also available for Solidity development on Polka VM. You just have to look up Polkadot Hardhat and Hardhat Polkadot and Foundry Polkadot. You'll be able to find them as well if you are more interested in using CLI development. Now, the advantages of CLI coding is that they can create local nodes. Then these are compatible with wallets and other tooling. There's lots of scripting capabilities for more elaborate development. They're flexible. They can run in a terminal inside your IDEs. Some of them even have front-end development components. And most of all, they create reproducible environments that you can share with other developers, especially when you're working on a team project. But here's where I also have to bring in the disadvantages. I'm not here to dunk on anything. If you prefer the CLI, by all means, power to you. But tonight I'm talking about the strengths of particularly Remix. So the disadvantages we have here is, first of all, there's a headache in dealing with package managers when it comes to CLI tooling. If you saw earlier in the table, we have either to deal with Git submodules or NPM, most importantly NPM, of course. And this can result in incompatible or conflicting library imports. And why I have an exclamation mark on this is that I want to take a moment to address why CLI tooling in blockchain actually creates quite a few issues when vibe coding. Now, we're not against vibe coding. You are welcome to vibe code in the Solidity Polkadot Solidity Hackathon 2026. But the problem with trying to vibe code with environments like Hardhat is that some LLMs have a lot of trouble digging through the compatible types of libraries that are needed, and sometimes you get conflicts in deployment scripts because they've imported two libraries that are not compatible with each other. Why I'm saying this is something that should be kept in mind is because when you're dealing with these environments that have these kind of problems, these things that clash, you really don't want to be wasting your time, because we're already 6 days into March. The Polkadot Solidity Hackathon ends on the 20th of March. You only have 14 days left. You don't want to be, burning up precious time dealing and fighting with your vibe coding IDE over compatibility issues. If you really want to focus, laser focus on Solidity itself, this is where Remix comes in handy. And if you're actually having trouble, if you're seeing the signs of trouble of compatibility in your vibe coding software, if you're using Claude Code, I actually have not tried it with Claude Code, but I've tried it with ChatGPT, Gemini, DeepSeek. They all seem to have this. They all seem to trip on similar issues. This is partly due to documentation, partly due to rapid changes, breaking changes in Ethereum tooling. So, again, nothing against vibe coding, nothing against that. But if you're facing trouble, and you really want to focus on Solidity, I suggest using the Remix IDE. CLI tooling can be overwhelming for less experienced devs, and including people who really want to focus on smart contract development. It's better to just go and focus on your smart contract instead. Some of these have inflexible signing mechanisms. Some of them can be scripted to have very powerful signing mechanisms, but most of us understand Ethereum and, of course, the Ethereum wallets that we will use to interact both with Ethereum and with Polkadot Hub as our browser wallets or our phone wallets, just like what we use with MetaMask and through Wallet Connect on our phone. And of course, like I mentioned, can be very frustrating to be debugged, especially when the LLM or the vibe coding tool screws up. Without further ado, I like to introduce you to the Remix IDE at remix.ethereum.org. Now, why this is a great IDE is because it runs in your browser. You can download it. There's a desktop binary available, but this can run on a browser with a decent amount of memory. The requirements are very low, and in fact, any device running a decently maintained Chromium browser, that can be Google Chrome, Microsoft Edge, Opera, Vivaldi, plenty of them out there. It does not run as well in Firefox, but I'm not going to rule it out. Again, it can work. It has worked for some people, but if you're facing issues in Firefox, just grab yourself a Chromium browser. That will be much smoother for you. Okay. And next one would be getting to know the Remix interface. In fact, why don't we just go straight to Remix? And let me just switch my screen. to transfer the window over. Quickly check. And apparently, I think we are out of time for today. But just to look at Remix right here, this is just the IDE that I was trying to show you just now. You can access it at remix.ethereum.io. And something I'd like to quickly announce is that this is also available for Revive for Polka VM, and you can access that at remix.polkadot.io. Yep. I hope I've been able to whet your appetite on Remix and basically whet your appetite on Solidity for that matter. And when you have the time, do check out plenty of the resources available on polkadot.hackathon.com. I hope to see you all participating. I can't wait to see your submissions for the Polkadot Solidity Hackathon 2026. I'll have to pass it on to the next presenter right now. So thanks for watching. Take care, everybody, and good night.
Hey guys, can you hear me? Okay, awesome. So I will get started then. I cannot send messages in the chat. I'm trying to connect to the platform because there are some links that I would like to share you with you. But yeah, in any case, I will get started and I will see if I can get connected after that. So yeah, let me share my screen really quick and we can get started. Present review. So could you please confirm if you can see my presentation here? This one. Can you see my screen? Awesome, perfect. So yeah, let's get started. So yeah, it's a pleasure for me to be here. Today I'm going to talk about PVM and cross VM on Polkadot Hub. We only have 30 minutes, so I'm gonna try to be as quick as possible. Before just diving into like the main topics of the presentation, I would like to briefly introduce myself. That's me. My name is Nicolas Hussein. I do developer relations at Papermoon. Papermoon is a company that provides, thank you, that provides developer relations as a service, and one of our customers is Polkadot. So we are the maintainers of the Polkadot documentation. And we also have been testing some of the latest Polkadot products, and one of those products is the PVM. So this presentation is going to be focused on that, on PVM, and also how you can deploy EVM and PVM contracts and make them interact with each other or talk to each other. But yeah, I think that's pretty much it. If you have any question during the presentation, just feel free to drop the question in the chat. I will try to read them all. Yeah, let's get started. So the idea of this presentation is that I can show you guys like a theoretical portion, because I'm going to split the presentation in two parts. First, a theoretical portion of the presentation is going to be focused on EVM and PVM. What is PVM, how it differs from EVM, and what are the main advantages of that. And the second part of the presentation is going to be like a demo, which is like, in my opinion, the most interesting part. But just a quick disclaimer, this presentation is not going to be like focus on the most technical details on how PVM works, on, for example, how the PVM architecture works, or the details of the PVM executor, etc., etc. The idea is just to give you like a glimpse of, or maybe a high-level overview of what is PVM, so you can grab all that knowledge for the hackathon and use that. So the thing is that we have in Polkadot something called the Polkadot Hub, which is the basically a chain. It's one chain. It was previously known as the Polkadot Asset Hub, and now it was renamed to Polkadot Hub. And this chain basically runs two execution environments on the same chain. We have the EVM, which is something that you probably already know, and the PVM, which is what we are going to talk about. The interesting part here is that both execution environments are going to share the same address space and the same JSON RPC endpoint. So your existing tooling, let's say Hardhat, EtherJS, Foundry, etc., they all are going to work with both execution environments, with the EVM and the PVM. It's important to consider that there are some cases that you may need, for example, to use some plugins, some Polkadot plugins for this. But generally speaking, the idea is that you can use the same tooling that you may use for your EVM development pathway, apply in PVM. And something interesting here is that a contract that is deployed to one execution environment, let's say that we deploy a contract using EVM, can call and can interact with the contract that is deployed using PVM. And I will show you in the demo how exactly you can do that. So let's start first with the environment that you already know, which is EVM. And as you may know, the EVM is a stack machine. Solidity basically compiles down to opcodes, and every opcode has a gas cost. And this gas model is what makes the execution predictable and trustworthy across thousands of independent nodes, right? But here's the thing. Gas is also a hard ceiling on computation. Every loop burns it, every storage read costs it. And if you go over the block gas limit, your transaction simply doesn't run. For most contracts, that's fine. Let's say a token transfer, a DAO vote, a swap, all is well, like within the limit. But the moment your logic gets heavier, that ceiling starts to feel like a wall. And that's exactly what I'm going to show you in the next slide. So as you can see in the screen, these examples aren't just edge cases. Think about, for example, of zero knowledge proof verification, which needs repeated field arithmetic, many multiplications per call, and the gas adds up fast. Or, for example, on-chain game logic that runs physics or path finding algorithm which ties loops that growth with the game state. Or also we have the heavy DeFi math examples, for example, pricing cars, AAM rebalancing, etc., that hits limits of scale. And here's the interesting part. When you need a cryptographic operation that isn't, for example, part of the EVM precompiled set, you already know that we have like a set of predefined EVM precompiles. If you need to do an operation that isn't part of that set, you have to implement it by yourself in Solidity, opcode by opcode. There is no way, thank you. There is no way to just grab, for example, let's say a battles tested library and call it from your contract. Let's say that we have a Rust battle test library regarding cryptographic operations. There's no way to do that. So that's exactly the gap that PVM is trying to, or is designed to fill in. So here's where PVM comes to the table. And here's where I'm going to introduce you guys PVM. So PVM, also known as PolkaVM, is the second execution environment of this Polkadot hub chain. It's not a separate chain, it's not an L2, it's not a bridge, it's just an execution environment. That's it. It's managed by something called Palette Rebuy. Here you have the link to the repo, which basically it's a module that lives in the Polkadot SDK runtime and runs both executor, the EVM executor and the PVM executor, and also it routes the calls between them all. So now here's something very interesting. You can write PVM contracts in two different ways. You can compile Solidity with Resolc instead of using Sol-C. Resolc is a compiler that was designed to compile down to PVM. So in that case, for example, let's imagine that you are using Hardhat. You just need to swap the compiler configuration in your Hardhat config. The code will stay the same, and you will get PVM bytecode. Or you can write Rust directly, for example. You can compile down that to RISC-V bytecode and deploy it as a binary, and that will be all. Either way, the contracts will land in a normal Ethereum address. It will respond to the same JSON RPC endpoint, and it will be callable from MetaMask, EtherJS, Hardhat, exactly the same way as you will do with other contracts, right? So these are some of the main advantages of PVM. You can take a look at the PolkaVM repo. I'm going to share you the repo in the chat. Let me see if I can just send links in the chat. Give me 1 second. Continue. Oh, it says an error occurred, but it's not your fault. Okay. In any case, I can share it in the chat. I'm not sure if I can share it somewhere else. Some of the links that I have, maybe in the private chat. Can I send this in the private chat and then it's forwarded to the public chat, or is that impossible? I mean, in any case, I will move on with the presentation, and if this is something we can do, the OpenGuild guys will let me know. So regarding the advantages of PVM, some of the most important parts here are the performance. If you check some of the benchmarks that were published in the PolkaVM repo, you will see how PVM was compared against other VMs, other virtual machines. For example, Wastime, Wasmer, Solana, RBPF, and others. PolkaVM comes out ahead of all of them with roughly 1.3 or to 1.7 times overhead versus bare metal, which is pretty interesting. The security point is also an state design goal. All the contracts will run in a separate process, so a compromised contract cannot reach outside its execution boundaries. And since you are writing Rust, any contract that compiles to the non-standard library is available to you, meaning that the entire Rust ecosystem is there for you. You don't need like extra work. And also something that is very important and that has been described in the Polkadot documentation, is that EVM and PVM would work as complementary. So EVM is meant for compatibility, while PVM is meant for optimized execution. The idea is that you can use both. And to understand how you can use both, let's see that through the demos. So yeah, let's check the demos. Is there any questions so far? Otherwise, I will stop presenting this screen, and I will show you guys the demo. Okay, thank you. Share the screen. Cool. Okay, I don't see any question in the chat, so I will move forward. Now you should see my VS Code tab. Do you need to zoom in here, or that's fine? So for these demos, I prepared 3 projects where I'm going to show you guys how EVM and PVM can interact with each other, but I'm going to do this in a progressive way. So just a quick disclaimer before we get into the 3 demos. Each demo will need these environment variables. So you will have to create a Polkadot account. You will have to found that account. I'm going to show you how. You can check the Polkadot documentation here. You are not see you cannot see the screen, right? Yeah, you are still seeing the Visual Studio Code. Let me reshare the screen and share my screen, entire screen, this one. Yeah, so you can check this page, Smart Contracts Connect, and you will see how you can connect to the Polkadot Hub and found an account using the faucet, which is Polkadot, faucet.polkadot.io. And the address that you will get, you will have to derive the private key of that address and put it here. And also add this hub RPC URL. Once you do that, you can just move on with the demos. So for the first demo, I cannot see if I'm sharing the screen correctly, but if you guys cannot see, just let me know. So the first example that I wanted to show you guys is this one. So I define a simple counter contract. As you can see, this is like a super simple contract where I define an increment function, a get count function, an event, and that's it. Super simple. And the idea of this contract is to be compiled down to EVM. It's going to be compiled with Solc, which is like the default EVM compiler. And also I defined this other contract, which is called call counter, which defines an interface, which is exactly the same interface that this contract is applying. And basically this call counter is going to be, this is just like a kind of a proxy contract that will call all the functions that are defined in the counter. But the idea of this contract is to be compiled down to PVM. So we will have an EVM contract here and then a PVM contract here. If you go to my Hardhat config, you will see that you have to define that through the Hardhat Polkadot utility, which is here, is documented here. If you go to development environments, Hardhat, oh, sorry, this is like a kind of a bug that I have in my browser. Let me see if I can show you here. 1 second, please. Yeah, it's here. You can see this for sure. Yeah. If you go to the docs Polkadot smart contract dev environments Hardhat page, the PVM page, you will have here the documentation of Hardhat Polkadot, which is the plugin that I will be using for this demo. So if you come back here and you see the configuration that I have, you will see that at some point in the networks, I have something defined as hub EVM and then as hub. And the only difference between them is that hub EVM has an EVM target as a compilation target, and the other one has the PVM target. That's it. The rest stays the same. So I wrote this demo script where you can see, I'm not going to go line by line in the script, but I'm going to show you just the most important part of the script. So basically I have a compilation function that will grab the network. So we will pass here if we are compiling down to EVM or if we are compiling down to PVM. It will load the artifacts, etc., save the bytecode, etc. But here's the main function. So first of all, we are going to compile down and deploy the EVM contract, which is this one, the counter. You see here that this is the counter, this is the artifact, the ABI, etc. We deploy that. We get the counter address of the contract. And then what we are going to do is grab the call counter contract, compile down to PVM, and do the same process. We compile, we load the artifact, we deploy it. And when we deploy this, you will see that this call counter contract has a constructor that receives the counter address. And in the demo, what I'm doing here is that I'm linking it's here. I'm linking the call counter PVM contract to the EVM contract, because counter address is the EVM contract, is the EVM contract address that we deployed previously. So basically, I'm going to deploy the PVM contract here, and now this is the interesting part. I'm going to make them interact with each other. So, for example, once the contract is deployed, you can check here, somewhere here. Yeah, we can call increment basically, and when we do this, basically what is happening is that we are going. How do you compile PVM with EVM? We compile these PVM contracts using this configuration in the Hackathon config, and we will compile the EVM contract with this configuration. That's why in the demo, I have a compile function that will grab a network that will say npx hardhat compile and the network. And depending on the network that you will use, it will grab the target. So if the network says EVM, for example, have EVM, it will go to the hardhat config. It will see, okay, this is the network that is being used, which uses the target EVM. If I send this as a parameter, it will grab this target and it will compile down to PVM. I hope that's clear, Telix Goldens. So yeah, as I was saying, in this part, you will see that this is going to call the contract, is going to perform this function called increment. If you go to the PVM contract that we deploy, call increment basically grabs the contract that is linked here, and it call increment. So basically, we are calling this function call increment to call under the hood to this function. So let's run the demo so you can see how this works. Now I'm going to show you guys the whole terminal. So basically, these are the logs that I defined. So this is my deploy address. This is the amount of test token that I have. This is what is happening, and this may answer your question, Telix. So npx hardhat compile. This is the network that we define. Have EVM. Again, if you go to the hardhat config, if you say have EVM, this will use the EVM target. So the contract that is compiled here is going to use EVM bytecode. I save the EVM bytecode here in, I think it's bytecode EVM counter. So this is the bytecode of the counter contract. And the same happens with the PVM side. So I compile this down to PVM using hub. If you check the hardhat config, go to hub, you will see a target is PVM. So whenever we are doing network hub, we are using this target. The bytecode of this other contract is saved under PVM call counter. So if we go to bytecode, PVM call counter, you will see that this is the bytecode. Something pretty interesting is that all the PVM contracts have this prefix, which is 505. So whenever you see this means that this is a PVM contract. Otherwise, you are using a RISC-V contract. And here in the cross VM call, you will see that the PVM call counter, which has a link to the EVM contract, is calling the increment function there, is root by Palette Revive. And here we have the transaction. Let's see if this has been deployed correctly. So let's grab the EVM contract address. Let's go here. Let's go to the blog explorer. Here we have the address of the contract. You can see it has one transaction, which is the contract creation probably. Yep. So if you go to the contract, you will see that here we have the same bytecode that we have here in the counter. For example, if I do this, I have like one instance of this exact bytecode. And we can do exactly the same with the PVM contract. So let's do it very quickly. this one. I'm gonna duplicate this tab. Let's go to this address. And you will see that here I will have the same PBM bytecode, which is quite larger compared to the EBM bytecode because this is 65. And if we compare this to the thing that we compiled down, you will see that this is exactly the same thing. Yeah. It's not. Oh, yeah, it should be. It's 50564, and if I go here, 50564, yeah, it's exactly the same thing. Maybe I didn't copy this correctly, but it's the same thing. So yeah, and here in the transaction you can see like how the interaction between both contracts happen. So I'm running out of time, but I'm really want to show you like the rest of the examples. So I'm gonna move like kind of quicker here. So here I also have a second example where I define a Rust contract, which is this one. For this, I have to install the Polka VM derived dependency and also the PalRio API dependency. And you will see that defining a Rust contract is pretty easy if you check this syntax. I'm gonna share all the repos here with you guys so you can have a look at it. But basically, there are two functions that needs to be defined for Rust contracts. One is deploy and the other one is call. And basically, when you have these two functions, you just have a smart contracts using Rust. Something interesting here is that in this case, for example, this contract is just an other contract that will add an ENT with an INT, and that's it. So basically here we grab the input of the call. We assume that the first 4 bytes are going to be the selector of the function, and the rest, the first part is going to be the first parameter, and the second part is going to be the second parameter. So that's what is happening here. We grab the first part of the parameters, and we say, okay, this is A. We grab the second part of the parameter, and we say, okay, this is B. We perform the sum here, and then we return the output. That's pretty much it. This is like the most simple Rust contract that you will see. Basically, what I wanted to show you guys is that you can actually go to the demo, run the demo, and while this is running, I'm going to show you the script that I created for this. That is basically what is happening here. You will see that here I have some functions just to load the blow of the contracts. The same that happened in the previous demo, just get the deployer, the address of the deployer, etc. I'm deploying the contract. Basically, I grab the blob, the bytecode, I create the bytecode, sorry, I deploy the contract using send transaction. And you will see here that basically here is the address, etc., and I'm calling the add function with the values, for example, 3 and 5. So for example, what is happening here is that I deploy the contract to this address, and if we check the Explorer, we will have the address here. This is the bytecode of the contract. If you go to the transactions, the first transaction that they did, that was like just calling add 3 and 5, it's here. And you can check this in the Explorer by going here. And if you check the details, you will see that here, this is the add selector. And here you have 5 and 3. So this means that this is performing the sum. And here you have the output in the script, 8. For example, then I call with 100 and 200, and you have 300, and that's it. And you can then check this transaction hash. And lastly, because just I'm running out of time, I only have 1 minute left, but this is like the most important demo that I wanted to show you guys. I have here a Rust contract that is going to interact with the Solidity contract. So basically, you will see here, I have this Solidity contract that is defined by this interface, iFibonacci, and the contract Fibonacci caller basically grabs the interface and just call a Fibonacci function. if we go to the Rust contract, the Rust part, I define here a Rust contract with the deploy and the call function. And you will see that here I'm doing something kind of similar, but in this case, I'm grabbing the input, I'm getting we skip like the selector part and we grab the rest, and we say the rest is going to be our parameter, in this case, n for Fibonacci. And with that parameter, we call something called Fibonacci here, that if you check, this is a Rust function. I'm going to share the repo, no worries. This is a Rust function that basically is performing just raw Rust operation. This is literally Rust. There is nothing else. And we come back to the contract after executing Rust like logic, and we output the result. So in the demo that I created, basically, I'm doing kind of the same thing. Let me open the terminal. Let me clear the window, npm run demo. And this basically what it's going to do is going to deploy the Solidity interface. Here I'm deploying the Solidity interface. Here I'm deploying the Rust contract. And then I'm just calling the Solidity interface, and I'm saying, hey, perform the compute Fibonacci function with this number. And this is under the hood calling the Rust contract, right? So if you check here, this is the output. And here I'm just deploying the Rust contract, deploying the Fibonacci, the Fibonacci interface. And I'm call one contract through the interface, through the Solidity interface. In this case, for example, I'm calling this with number 10, which give us 55, and then I'm calling with a big number, so you can see like this is like heavy computation, and this is running entirely on Rust. So yeah, that's pretty much it. Not sure if you have guys any questions. Sorry that I had to run, but we only have 30 minutes. I'm gonna publish this in the Papermoon repo. So I cannot share the share links in the chat. I'm not sure why, but I will publish the 3 demos here in this repo, so you can check it out. And yeah, I think that's pretty much it. Not sure if you guys have any questions, or maybe we need to pass it to the next speaker. All good? Okay. Okay, awesome. So yeah, thank you very much, guys, and that could be all from me. And yeah, good luck for this hackathon. Bye bye.
Hello, sound check. 1, 2, 3. I hope things good. Hello. Oh, I see sound signal. Okay, sounds good. Gonna switch to share screen. This one and slideshow. Oops, that's way beginning. All right, there you go. Perfect. Okay. Just give like a quick moment just before, just so we can, kind of like collect your thoughts, everything right after that previous presentation. But anyway, hey guys, hope everyone's doing well. Welcome to this next workshop, the Developer Guide to Earning with Frontends workshops. My name is zxstim. I'm the DevRel for Bifrost. I'll walk you through this workshop. We have 2 parts. First one is liquid staking fundamentals, and then the next one is the one about frontends, because I need to give you some context regarding like how do you earn with the frontends. So our Bifrost protocol, we have this very unique mechanism, RSP mechanism, for you to earn income very easily. So the workshop will be quick note. The workshop will be more like an overview. All details can be found on our developer documentations. We also have videos as well, so feel free to hop over and just take a look at it. So yeah, this one is more of an overview. Nothing, go into details, everything, because within Bifrost, who believe in AI assisted to do a better job than even me. I think my role should be like giving you some ideas and helping you, inspiring you to be able to work on something to make some money. Anyway, next. Sorry. Uh, okay. So here's the QR to this presentation. If you would like to follow along on your own, so feel free to scan it. You have your phone. You can grab it, scan it, or if you're on your phone, a little bit hard. But yeah, I give you guys like a minute or two for you to do some scan, and then move on to the next slide. So just kind of like chill a little bit. Okay, hope you guys are done. So we're gonna hop over to the first part, which is liquid staking fundamentals. So give you some context, what Bifrost is. I have to kind of explain to you guys what is traditional staking on Polkadot. So traditional staking Polkadot include on Polkadot we have these nomination pools. Essentially, it's like these collective. Think of them as like collective, where dot holders can join, or basically means that you deposit your dot into these nomination pools, and then so you become essentially pool members into this. So basically, you're pooling your nominations, and then each of these nomination pool would have a nominator. Right? Some of them actually have more. So once your dot is delegated to different nominator and depending on nomination pool, and then based on the nominated proof of stake mechanism of Polkadot, different nominator will select randomly different validators to build and propose blocks to get included into the Polkadot blockchain. Right. However, so this is how Polkadot does staking at the moment. This is the vanilla way of doing staking, and there's some disadvantages of this approach, namely these attributes. So you have locked liquidity. So essentially, once you deposit your dot into this nomination pool, essentially your dot is just locked in there. Right? You're not going to use it. Of course, you involve with staking, you will get your yield on the stuff, but then your liquidity is inside. You'll not be able to. You cannot use it anymore. Right? So there's an inefficiency when it comes to this, and you cannot use it anymore. So no on-chain operativity. You cannot use it. Cannot get involved with any other yield-making opportunities. You cannot take this liquidity into anything else. So this is and then you don't also don't have voting power. So once you're in a nomination pool, you don't get to vote on proposals and so on. So and you also, for you to unlock your dot from nomination pool at the moment, it's 28 days unlock period. It's really long. So then but of course there's two parts of it that's very important for staking, especially with nomination pools, is you are participating in decentralizing Polkadot, your partner, and also you are helping to secure Polkadot, the chain, right? So these are the two things. But of course, it comes with some of the drawbacks, the 5 points over here. But when it comes to Bifrost liquid staking, it's slightly different. So once you have your dot and you with Bifrost liquid staking solutions, you take your dot and then you would interact with Bifrost liquid staking module. And what it does is basically you're sending your dot into this quote. You can think of that as like a program or like a smart contract. But Bifrost is basically like a parachain. So it's like a smart contract on steroid. It's massive. It's like a whole chain of itself, its own block space and everything. So you're sending your dot into this program on-chain program, and works like a smart contract. And then in return, Bifrost will, but the module will mint of an equivalent amount of V dot and send it back to you. So V dot, this is the one that will give you the magic, the Bifrost magic going forward. But then the Bifrost liquid staking module also follow the same process, just like normal staking. We don't violate the protocol anyway, or we don't get treated any different, except the part that we take your dot, we pull that together, and then we have this system that basically we have this Bifrost nominator, and it's like a intelligent system that will pick and choose automatically pick and choose what kind of validator, kind of stuff. based on the nominated proof of stake mechanism of Polkadot. So what's the advantage? Big one is liquidity unlock. Remember, if you remember, you will get the V dot. This V dot also has value because even your capital is locked. This V dot still also carries value. It represents a claim of your it represent a claim to your original dot that you deposit. So it has value in it. So it has so then you can start participating in different or like different DeFi campaigns or DeFi protocols. For example, you can mint VDOT and participate in hydration. You can trade on there, you can LP on there, you can lock it, lending, all that kind of stuff. So both of these things are available in many places that we already have done integrations. So your liquidity is unlocked. You can do a bunch of stuff with it. That means your capital efficiency is much higher compared to this. Your capital is locked. You can do so. Basically, you are not only getting yield from providing stake to proof of stake, you also can be able to participate in DeFi. So you're getting extra yield. And I have another diagram explaining this in details. And the other one is like the VDOT is very easy to go cross chain because we leverage a hybrid bridge, and we take this VDOT like go tons of places, Asset Hub, Bifrost chain, hydrations, and the hydration is XCM. But then you can also bridge that to other ecosystem as well, or vice versa. So there's a lot of advantages for holding VDOT. You also have full voting power retentions. We have a voting module allowing you to still be able to vote in OpenGuild proposal with your VDOT. Because we know how much you stake inside the system, so we will still be able to provide you the service. We have flexible redemption period. So there are two ways for you to redeem. You can either redeem by going through a normal process, which is you request redemptions. So when we would do the whole process, just like nomination pool, then it would take like a while, like 28 days, exactly the same. Except we also have the ability for you to swap out of it. So VDOT, you can swap over to DOT directly, so that you get instant redemption. So your VDOT turn to DOT, of course, cost a little fee, but if you want it fast, that's what you need to do. We also have like other things like like instant redemption, that kind of stuff, which is somewhat similar to similar to like swap, except we have an instant redemption pool that is incentivized differently. Of course, same thing. Because we Bifrost, we participate in nomination pool as well, like the same proof of stake that same as everyone. That means you're still helping Polkadot to be more decentralized, and you're also helping to secure the chain. So the same thing, except with a lot more perks. Okay, now go a little bit deeper on how exactly what I mean by more capital efficient, or what is the benefit here, right? How much more I can earn. So I'll give you like a simple breakdown over here. So let's say day 0, which is right now. Let's say right now you got 10 dot, and you go straight to Bifrost like a staking module. You deposit it in. This rate is a little bit a while ago, but just use this as a reference. So you take your dot, you deposit into the Bifrost liquid staking modules. You go to app.bifrost.io. You can do this one. Your 10 dot goes in. You will mint, in this case, 6.83 V dot out. So then now your dot is being proactively participate in consensus, is earning proof of stake yield from there. Now you take your V dot, you go to another chain, for example, hydration. Let's take hydration as an example. So hydration allows you to LP plus farm APR, which is let's say okay, well let's say the LP plus farm APR right now on hydrations is 1% plus 9% is equal to 10%. Right. So then after 365 days, you take from your hydrations, you take it out, you would end up with 7.51 V dot, and then once you exchange 7.51 V dot, you would get 12.48 dot. You get way more than you would have gotten if you are just doing like just the 10 dot at the end. So you got way more. So the effective APY that you would get is about 15%. So you're getting a much better deal compared to if you just staking into nomination pool. is because you essentially it's like a form of leverage. You locking it in, it's still participating in consensus, you're still earning yield, but then you have a representation of your stake, and then you can start using that as basically the same, roughly equivalent value. Go to different protocol, they will provide you extra incentives for you to do these things. So what's Bifrost USP? So USP, so traditional LSD protocol, for example, you think about on on the Ethereum side, you have Lido, you have Rocket Pool on these things, or just nomination pool, as I mentioned just before. On like different LSD provider. The one of the thing with what these one is, they usually just single ecosystem, so there's no standardization. What Bifrost offers is we offer many chains. So besides like VDOT, we also have VETH. We also have like a bunch of other like liquid staking tokens from different ecosystem. All of these liquid staking tokens will also share the same interface for you to interact with it. So then it's very easy. Once you integrate with one of them, it's basically you integrate with all of them. So then it's super easy for you to kind of like pick and choose what kind of product you want to get involved with. If you can do VDOT, you can do VETH, you can do like coming up, we have new liquid staking token as well. Of course, very decentralized. We take we take this idea very seriously for us. We have our own security process, all that kind of stuff, and making sure that the controls are properly set up. Then the biggest thing is the liquidity aggregation. So essentially, Bifrost acts as like the source of liquidity for everything. So whatever ecosystem that you interact with, basically everything gets bridged into Bifrost to act as accounting. So think of Bifrost as like a massive accounting, like accounting smart contract, right? So all the accounting is on there, all your stakes, everything is kept within Bifrost. We know at all times like how much you have in the ecosystem. So then it's also very nice is when all of these liquidity can be shared, regardless where you're bridging in. For example, if you have a liquid staking, if you have the VDOT on Asset Hub, or you have the VDOT on and the VDOT hydration, all these things share the same liquidity on Bifrost, and whatever the stuff on there is just representation. So what we can also have is just much higher liquidity on Bifrost for you to do a lot more things. So when you swap, less slippage. If you farm, you get much bigger farm. Um, Governance usage, of course, a lot of other liquid staking provider, they don't provide you governance participation compared to Bifrost. So Bifrost, we try our best to, if there's a way to participate in some form of governance with the tokens, we will do our best to be able to pass you that right during the staking, just like as much as possible. For some chain, it's not possible. For example, for Ethereum, we cannot do it because Ethereum doesn't have a ecosystem governance like Polkadot, like with OpenGuild. So we don't offer that service. But for Polkadot, we do offer voting representation with your stake all in one. Set a gas fee on Bifrost chain. You can set a bunch of things as gas fee. Super simple, and increase utility for the LST token. So that's the very specific USP for us. Which the positioning, which kind of reinforce the positioning that Bifrost has, which is essentially we want to be this one-stop shop for liquid staking for basically everyone, leveraging the power of Polkadot to run the parachain, the Bifrost parachain. But essentially, we would provide a service to a bunch of different ecosystem, bunch of different chains, and all of them will get all the quality will get pulled, aggregated into Bifrost, ensuring the best user experience and also developer experience, because all of these things would share the same interface, so that it's super easy to integrate with them. Super easy. Now let's go to next part. I will next part important, which is the front end part. So what does it? What do when I say you can earn with front ends? What does that mean? So essentially, if you look at that, here's like a somewhat like you zoom back out a little bit. This is how this whole SLPX protocol on all like Bifrost liquid staking module look like, with this ability to cross chain. So on a bunch of, so how does Bifrost interact with a bunch of different chains. Like for example, like Asset Hub, or for example, Ethereum, for example, Base or Hydration, all these things. So we have on like for general purpose chain, like on like Asset Hub, we have this contract called SRPX deploy on there, and then with this SRPX like contract, it would act like a relay or like an outpost contract for user on those chains to interact with. In this hackathon, for this hackathon, you think of Asset Help, but there's also like other options we offer as well. We're leveraging the capability of Hybrid Bridge, which is a very safe, secure bridging protocol based on proof rather than like multi-sigs, which is very important for DeFi, provided the level of TVL that we're handling. So we use Hybrid Bridge for safety on that part. So then all these SRPX provide basically a super, super simple way to integrate for everyone, for RSP. RSP represent for rewards share program that we have. So essentially, RSP would allows you to, as a developer, you can build front ends. So and then the only thing you need to do is go in our forum, sign up and get a channel ID for us to know like okay which who like to attribute which stake belongs to who for us to do the split, the fee split. But fundamentally, for you can build front ends on all of these chains. You can build an Asset Hub, you can build Ethereum, you can build Base, Arbitrum, etc., etc. We have a lot of options. So you can go there, you build all these front ends, or you can even build protocols on top of it, and you still do the same thing. Basically, we have all these accountings nailed down, so you can build front ends. Or if you want to go from a protocol, no issues, no problem. We split you regardless. So, but the one that I see very often is front because you don't have to pay for smart contract auditing, that kind of stuff. So starting out front is like perfect, beginning, perfect starting point for you to start building up your user base, community, all that kind of stuff. And then if you feel like, oh wow, I got a lot of users, I got a tons of people. Of course, look, you can build on you can build apps on web apps. You can build desktop apps. You can build apps on mobile, on iPad, all that kind of stuff. So there's tons of things you can build front ends. So think about front ends as like it's not just web apps. It can also be mobile apps. It can also be agents that interact with this protocol. So it can be like super flexible. Think about it. And you can treat SRPX essentially like an API layer. So you can interact with them. And permissionless API, that means anyone can interact with it. The only thing, if you don't need to uh, get our permission to interact with SRPX protocol, which is on these like outpost relay that lives on all those different chains. But if you want to get the fee split, you have to open a forum proposal, and then we set it up for you. So once you do all the setup, everything, and you mint, people go through your front ends, right, or your protocol, whichever you feel comfortable with to build. We would know how much tokens has been minted via your quote unquote like channel ID, and based on that, we would do a referral split. It is up to 50% LSC fee that we collect. So right now we collect 10%. So for example, someone, the TVL is like, $1 million, and then the $1 million would generate like X amount of staking revenue, like which is in the form of dot. We would take 10% of that, and then within that 10%, we can split up to 50% of that 10%. So you get like 5% of all the fees that so you get basically 5% of the staking, the staking yield essentially. You think about that. So so then it's so you basically you can earn very quickly. You don't have to go through the whole process or try to get product market fit. LST is like a pre-proven like a use case for liquid staking for like within DeFi. So then it's pretty. You can go to market immediately, set up a front end, which with AI at the moment is super quick for you to build, and just go to market and launch. And not just that, we also will give you some help. So we have a Bifrost builder program, which will provide you with grants, liquidity, right? Get some grants. Like if you need some, like for example, you build front ends and it's like, oh wow, I'm finished. I got the front end, everything ready, and I want to like launch, right? So then if you want a little bit easier start, you can start like a rewards program and all these things to how to get people like to attract to you. So we can also provide you with small grants for you to do like go to market marketing, all that kind of stuff. So of course it's not like crazy amount, and we stop giving grants for you just build, right? Because we have with AI at the moment we have a lot of people building stuff already. So we want people to actually be able to bring things to market. That's something that we focus in. um, we also there's we can also give you a lot of marketing help. So quote unquote, like we can essentially closely working with us, you become like official dedicated front end, quote unquote, like have like a partner front end, and then we will help check your front end, making sure everything's good. We help you to feel like, okay, is the UX feeling well, that kind of stuff. And then give you a couple tweets here and there for you to kind of get approached to the community, and for you to get integrated, for you, and give you as like that initial boost when you get started. Of course, most of the work it should be driven by you. We only can help you to. It's like we only can give you a little bit extra, like give it a little extra boost. But everything is you and you, but like basically like you should be the driver of this car, like not us. Like we just help it along the way. Technical help. So I'm here with the Bifrost team. I would, yeah, if your platform is open source, which for you to qualify for the grants you need to be, then I take a look at the source code, and then I will give you technical help. I give you just things you should be mindful of, that kind of stuff. All those things, even helping you with the UX or something you get stuck. Give me, ping me, and then I will give you some help on that. So a lot of tech. Also, these things like something we provide for free of charge, part of the Bifrost Builder program. And how to get there? So basically, you can go to this. You can scan the QR code, and then you can go to the website. Or if you're watching this on a desktop, you can grab your phone, do scan, you will go there. If not, then you can I can read you the website, which is developers.bifrost.io. Very simple. Developers with the S .bifrost.io. So you can go there, take a look. You see like we have all the resources on there, lots of write-ups. We have videos on the YouTube channels. We have like AI stuff. Everything's on there. Super easy to get started building front ends and start earning money. So, and that's it for the workshop. Thank you very much for joining. I wish you all good luck for the hackathon up ahead. Peace out. Yeah, enjoy. Yeah.